Okay, so today we're going to talk about rational exponents. For your math interactive notebook, your digital version, I want you to find the slides that are the light blue slides that we moved down, the first three. And you need to update them. And I believe they're currently slides 102 through 104 for you. You need to update them, and then you need to move them up to make them slides 94 through 96. And these are what the three slides look like, okay? So let's go, though, to our paper interactive notebook. And our TOC for today is rational exponents. They're going to be slides 94 through 96 after you move them up into position. And I'm on page 22 in my notebook. So I'm going to give you about half a minute here to get your TOC updated, and then we'll proceed with the handwritten notes. Okay, so once you have that done, go ahead and turn to page 22 in your notebook. Go ahead and put rational exponents at the top. And the reason why they're called rational exponents, where if you remember at the beginning of the year when we talked about the real number family, we talked about rational numbers versus irrational numbers. Rational numbers were numbers that were able to be written as a fraction. Okay, so that's going to go along with what our definition is here for rational exponents. So rational exponents are fractional exponents that represent a radical computation. So in other words, another way to write a radical is instead of writing it with a radical sign, we can represent it with a fractional exponent. So what does that look like symbolically? So say we have a number variable a, and it's going to be to a fractional exponent, and I'm going to call this e over I. And another way to represent this would be with a radical where I represents the index number and e represents the exponent of the radicand, or how many of the radicand that you have. Some people like to write this as a to the I, and the whole thing is to an e, using the power to power law. We're going to focus mainly here. Okay. So things we need to know, where e is an exponent representing how many of the radicand exists, and where I is an index number for the radical. So if we just have some, look at some basic things. If we had 25 to the 1/2 that would be equal to saying the square root of 25. 2 being the index number, and remember on a square root we don't actually see the index number, and we have 1 25. Then of course we could simplify that as a regular radical. This would be equal to 5. If I had 25 to the 1/3, that would be like having the cubed root of 25. Of course, the cubed root of 25 is not perfect, and I can't simplify it any further, so it would remain the cubed root of 25. What if I had 27 to the 1/3? Be the cubed root of 27, and if I prime factor 27, I know that 3 goes into 27 9 times, 3 goes into 9 3 times, and 3 goes into itself once. So in fact, I would be able to simplify that, and that would just equal 3, because 27 is a perfect cubed number. What about something like a to the 9/2? Well, square root of a to the 9th. Remember, if I did our division, 2 goes into 9 4 times, leaving a remainder of 1. So that would be like having a to the 4th radical square root of a. What if I have something like 3c to the 1/2? Well, the rules about exponents apply, and that is that every base has its own exponent. So this 1/2 is actually only applying to the c, whereas 3's exponent is 1. I just don't see it. So when I want to write this as a radical, that would be like saying 3 outside of the radical and c, the square root of c. If I have something written like 3c parentheses to the 1/2, then both of those would wind up under the radical. And that is how we can examine rational exponents. Once we take the rational exponent and change it into its radical, we can simplify it, or we can simplify it from a fraction as long as we're aware of what each piece of that rational exponent is telling us. And the top tells us how many of our base exists, and the bottom tells us to what root power, the nth root that we're looking for. And that is rational exponents. You have 2 guided practice problems that you need to do, 2 sets of guided practice problems in your Math Interactive notebook. I believe they're GP 14 and GP 15. So we'll be working on those the rest of class period.